Thank you. So final one up is Martin Green, and then we'll have a break for deliberation and come back. Can all of the judges stay a bit late, or should we try and do it for 5 still? What's the consensus?
As long as it's late.
Okay. So we'll aim to come back at 5, but we may delay to 5:15 if we need to.
Hello, I'm going to be talking about the work we did looking at task flow scheduling. This is work that interested me from my work in a large radiotherapy department. In particular, we're looking at what needs to happen before a patient can get treated. This tends to be quite a long series of tasks that need to be performed. I wanted to look at this because I was wondering if we could come up with better ways to make sure that we had fewer patients that we had to delay, that we used our resources effectively, and that we could ultimately look into bringing the time from the decision to treat a patient to the time that we actually treat them, to make that as short as possible, which will have clinical benefit. To model this process, I realised we had to consider 2 sorts of deadlines going on, which is called hard and soft. So a hard deadline needs to be done by a specific time. It's when the patient's turned up, or perhaps it's a criteria on which the department is judged. And then there's soft criteria, where it's just one of a series of tasks that need to happen coming up to a hard criteria. So I thought I'd start off with showing you where we managed to get to this weekend with the website before talking about the ultimate purpose of it and where we want to go forward. So for example, we want to add a course of tasks to a patient. So we can select them. And say, for example, we wanted to treat this gentleman's prostate for cancer with radiotherapy. We put in the time when we're starting the set of tasks and the deadline that we need to complete it by. So we added that, and we can see here a list of the outlining, the planning, the checked that needs to be done, and a current status of whether the task can now be done or if it's waiting other dependencies. So you'd build into this website all of the various workflows that are within your department. What we then want to see, rather than a patient view, is if you're one of the people on the ground, you want to see what work you've got to do to get these patients through. So at the moment, Dr. A here doesn't have any allocated tasks or weighted tasks until hopefully we refresh. We see that that prostate plan has now come through. So the doctor now seems that he needs to outline it. So you can say that he's doing that rather than somebody else picking up the task, and click start when he starts and stop when he's done. This allows data to be collected so we can see the actual time that these processes take, which is used in building these models. Now the Dr. A has done this, the next step is to plan the patient. So this is an example work list of a prostate planner. If we refresh, we see that at the bottom the planning action's been added only when the doctor has said that they're finished outlining. So again, we can start and complete that action, which will then drop it through to the third person in this chain here, a physicist, who has 2 potential roles. They can do the planning or they can measure. So they've got some of both checks here, and they, again, can start and stop the processes. So in this list of tasks, you notice the big thing that's missing that we didn't quite manage to achieve this weekend is what task is the priority. So we want to do the thing that's going to most likely mean that our patients are going to be treated at the times we need them treated. So to give an idea of the order of magnitude of this problem, for my department, we're looking at about 7,000 patients coming through a year. Maybe there's 10 tasks per patient and 40 members of staff that can do the various parts of this resource. I believe what we've developed so far is going to handle that scale going through. But the harder part is, as I say, this prediction, which is a highly constrained problem, because not only have we got the order dependency, we've also got the allocated resource, we've built in a model and started to put in the ability to specify this resource, or maybe you would be grabbing it in from other systems within the hospital. So the proposed simulation to work out what's most required is you first of all consider each patient separately, taking into account the resource availability in the whole department. So the department only needs to deal with that one patient. We work out from there when's the earliest time that we can start a task and when's the latest time we can start a task. And the difference between those we're calling the slack time, so the amount that you could delay something. In fact, because we're only looking at one patient, this is a lower bound on the slack time. So what we then do is, having looked at all tasks, choose which is got the least slack, allocate that, take the resource out and rerun.
Sorry, we're just having a debate. It's absolutely fantastic, but we're just having a general debate, Ben and I, because everything we've heard today, virtually everything, is hospital-based, secondary care-based, and that, of course, is from where many of you come from. I'm assuming you clever folk will be able, I'm directing this at you, will be able to take what you've just done here to a primary care and assign tasks, because 85% of all care takes place entirely within general practice, and yet if we came here today we'd just assume there were only hospitals. I am a GP, so I've got a conflict of interest about
So we saw earlier the ward application that was made that was an alternative as well as this. This is particularly looking at these soft deadlines, which you really only see, which I suspect you see, particularly in large departments, particularly where a lot of the work can happen without the patient present. Now, it could be entirely wrong, and this could be more widely applicable. I think there is potentially a lot of work to be done looking at sort of more creating sort of hard appointments and having patients in. That's not something I particularly looked at, and might possibly be slightly easier from the scheduling point of view. Well, I could be stood correct.
Yeah.
The PR man rather than
more as a P man than the developer, because the ideas have come from elsewhere. I mean, this does generalise, but perhaps not as far as patient appointment setting. So what this is good at, it will be good at, but the optimisation hasn't been built into the scheme. In the weekend, it will take an extra day. So, but it's a very generalisable solution.
Okay. As you probably know, there have been some quite nasty incidents involving underdose or, more seriously, overdose with radiotherapy. Does this help in any way to reduce errors like that? Or could it?
By managing the system better. So we put a lot of effort into putting systems in place in order to spot these errors. A lot of time is done making measurements and sort of double checking things. By having a sort of hard work list, or a work list like this that has to be followed, things go through, reduces the slight possibility of something being missed, which it is possible to occasionally occur. By managing what's going on better, perhaps, well, hopefully we'll stop having tight deadlines around which these tests need to happen. So I would hope so, but reality may differ.
Okay, thank you.
Thank you very much.